This example is called hostile brothers in rectangle. Suppose we have n brothers and we want to find the location of them in a rectangle in a way that the minimum distance between each pair of brothers is maximum. Okay, so the input parameters of this model is the dimension of the rectangle. For simplicity, we can assume that it has a square shape. So then we need to find out the location of each brother. So xi and yi of each brother should be found. And so in order to calculate the distance between each pair of brothers, for every I and j, we have to calculate this expression. Xi minus xj square plus yi minus yj square should be bigger than r square. And also the x should be within 0 and 1, which is the dimension of that rectangle, and y is between 0 and 1. Okay, so y is moving from here to here and x is moving from here to here. Okay, so in order to find out what is the optimal decision for this problem, we need to have a look at the Python code. So first of all, as usual, we have to import the required libraries as we did it here. We have defined it as an abstract model. I have defined the number of brothers as a parameter and made it mutable because we can be able to change it and update it. And also we are trying to find out, we define a set of I with the exact number of brothers. So range sets 1 and model n. J is the alias of the previous set I. L is the dimension of the board. Okay, and I define this function later. Okay, so there are 3 variables in this model: x, y, and r. So x is defined over I, y is defined over I. The bounds of both are between 0 and model L, and they are defined within non-negative reals, and we initialize them using this function initval. So a uniform number between 0 and 1 will be assigned to each variable, and then we have to calculate the distance between each pair of variables. Okay, so in order to do that, we have to create a constraint like C. Model.c is a constraint. It is defined over model I and model j, following the rule C1 rule. The C1 rule is defined for different situations. If we already know that the distance should be defined for different brothers, not themselves. Okay, so it means that if I and j is not equal to each other, then it means that the distance will be calculated at using model.xi model minus model.x model.xj square plus model.yi minus model.yj square, bigger than model.r square. Okay, that r is the minimum distance between them, and if they are equal to each other, then we have to skip the constraint. Okay, and the next line is describing the objective function, which is the given by expression equal to model r. We are telling Pyomo that the objective function is model r. The sense of optimization is maximization. We want to maximize the minimum distance between each pair, and we choose the solver as the IP-opt. Since it's nonlinear programming, we follow the IP-opt, and then we specify the model.n. We could put this data in a dat file and call that file, and the next step is creating the instance. Model.create instance will feed the data into the model and create the constraints and everything. Then we can ask Pyomo to solve the model, solve that specific instance for us, which will be done. Let me run the code for you. Okay, so first tab, second tab, third tab, and this one. This one will graphically show you what's happening. Okay, so if you want to test it for another set of number, for example, let's say 25 brothers, I rerun this section and the model will be run for a bigger number of brothers. Okay, you can still increase that number, let's say 40 brothers. So to see what's going on, so it takes more time, and then it's for 40 brothers. Okay, thank you very much for paying attention to this example.